Hey, Algebra 2. Let's go ahead and finish up Chapter 8 with Section 8.3. We're just going to graph rational functions in general. Okay, we're not going to really focus anymore on the transformation version of our rational functions, the idea of simple rational functions. We're going to focus more on that idea we've ended with at the end of 8.2, the representation where it's just a polynomial divided by polynomial, not the minus h plus k, just because not all of our rational functions will look at like that. They will look more like the p of x over q of x. Okay, so let's go ahead and talk about that. So let's just start with a generic rational function. Okay, that way we can talk about all the different pieces. Because our objective is to find asymptotes, intercepts, domain, and range of any rational function. Okay, so let's start with, let f of x equal p of x divided by q of x, q, x, be a simplified rational function where, p of x and q of x, same conditions, they're polynomials. I don't know why I can't write right now. That's funny. Polynomials. There we go, polynomials. And then q of x is not 0. Okay, same conditions from last time. So how are we going to find the x-intercepts of this? Well, what we would do is we would find the x, find, there we go. Find x-intercepts, right? There could be one, there could be multiple, there could actually be none, right? We'll have to see. Find x-intercepts of p of x, right? The x-intercepts of f of x are the x-intercepts of the numerator functions. So what are we going to do? We're going to set numerator equal to 0 and solve for x. Okay, that's what we do to find the x-intercepts of f of x. We're going to find the x-intercepts of our numerator. So that means take our numerator, set it equal to 0, and solve for x. Okay. Y-intercept of f of x, you know how to find that. It's find f of 0. Okay, you're going to be y-intercept experts by the time you leave my class. All right, now let's talk about the vertical asymptotes. This is how I'll abbreviate vertical asymptotes, and this is how I'll abbreviate horizontal asymptotes. The vertical asymptotes of f of x, how do we find that? Well, the vertical asymptotes happen where we get division by 0, right? So we want to figure out when q of x is equal to 0. So find the x-intercepts of q of x, right? Figure out what makes the denominator 0. So in other words, set denominator equal to 0. Den, I don't like that one. Even though it's the same length, we'll do denom. Denom. If I can write. Denom equal to 0 and solve for x. Okay, that's how we'll get our vertical asymptotes. Now, same as with the x-intercepts, we might have one vertical asymptote, sometimes we might have two, and sometimes we might have multiple. And then sometimes we might have none, as usual, okay? Just like with the x-intercepts and actually with the y-intercept too. The only difference is that with the y-intercept, we only ever have 0 or 1. And that's actually going to be the same for the horizontal asymptote. We're only going to have 0. Sorry, I don't know why it shifted up. There we go. We're only going to have either 0 or 1 horizontal asymptote. Okay. I don't know why it's like doing this to me. Let's do this. There we go. Okay. So, and there's actually more involved with the horizontal asymptote because we want to be able to find it for any rational function. Okay. So let's go ahead and talk about the rules. Let's first say, let m be the degree of p of x, and let n be the degree of q of x. Okay, so degree of the numerator, let me write it in the different colors to show you or to indicate. Degree of the numerator and the degree of the denominator. Okay, the horizontal asymptote, we're concerned with the degree of the numerator and the degree of the denominator, right? Degree meaning the exponent on the leading term, or the exponent, the biggest exponent, right? So here are the rules, okay? If m is bigger than n, so if the numerator has a bigger degree than the denominator, then for that case, we have no horizontal asymptote. Okay, if your numerator has a bigger degree than the denominator, then we have no horizontal asymptote. Okay, if our degrees are the same, which is what we've dealt with so far, what did we do? We divided the leading coefficients. Divide leading coefficients. And that'll be our horizontal asymptote. Okay, now the last case is what if the, sorry, that's an ugly sign. Let's make it better. There we go. What if our denominator, sorry, what if our numerator is smaller than the denominator as far as degree goes? Then our horizontal asymptote is automatically y equals 0. Okay, so you have 3 different options. Either you have no horizontal asymptote, you have a horizontal asymptote and you divide the leading coefficients, or you do have a horizontal asymptote and it's y equals 0. All right, this is going to be you're going to want to be able to reference this whenever you're finding all this information from rational functions, okay? Because this is going to be the general way to find all this information. And what better way to do that than to practice it? So let's go ahead and practice, okay? We're only going to have one example. We're going to have 4 different pieces to it. For each of these, we're going to find the asymptotes, intercepts, domain, range, and a few more points for the following rational functions. And then we're going to graph them in decimals. We're actually going to get to decimals this time, not like the last video. All right, so start with this one. Okay, let's start with our asymptotes. What are our asymptotes here? Let's start with the vertical. Okay, what do we do to find the vertical asymptotes? We set the denominator equal to 0. X squared plus 2 equals 0. Now from here, you might already see that you can't really get anything out of this, but just to confirm, the reason why is because if we move the 2 over, we have to subtract it. We get x squared equals -2, and we'll have to take the square root of a negative, which gives us a complex number. We're graphing in the real plane, so this is not going to be real. So because we have no real number here that makes this 0, there is no vertical asymptote. Okay, because there's no real number that makes the denominator 0. Okay, so we have no vertical asymptote. What about our horizontal asymptote? Let's look at the degrees. What's our m and what's our n? Okay, whenever we have a constant, the degree is 0. This has a degree of 2. Numerator is smaller than the denominator. What's our rule? It means that our horizontal asymptote is y equals 0. So because m is less than n, that means our horizontal asymptote is y equals 0. Okay. Now let's go ahead and find some intercepts. Let's start with the x. X-intercepts, what do? We set the numerator equal to 0. We get 4 equals 0, which is not true, right? So that means whenever you get something like that, when you don't have an x in the numerator, that means we have no x-intercepts. Okay, and that makes sense with what we found so far. Okay, what does that make sense with? It makes sense with the fact that we have a horizontal asymptote at y equals 0. Y equals 0 is the x-axis, right? The equation y equals 0 is the x-axis. If you have a horizontal asymptote there, I can't really touch it, which means I don't have an x-intercept, okay? So now let's go ahead and find our y-intercept. Okay, we do that by finding f of 0. Okay, and what is f of 0? 4 over 0 squared, which is 0, plus 2, which is equal to 4 over 2, which is 2. So our y-intercept is 0, 2. Cool. So now let's go ahead and find a few more points so we get a better idea of what this graph is going to look like. So let's start with, whenever we do this, we use our vertical asymptote. We don't have a vertical asymptote, so we can't do that. But we found a ordered pair at x equals 0. Let's go ahead and do 1 and -1. Let's do 2 points around that. So let's start with 1. So f of 1, what is that equal to? 4 over 1 squared plus 2. 1 squared is 1, so 1 plus 2 is 3. 4/3. Okay, so we have one ordered pair, 1 comma 4/3. Now let's do -1. 4 over -1 squared plus 2 is equal to, we have 4 over -1 squared is still 1. 1 plus 2 is still 3. So we get -1 comma 4/3. Okay. So we have 2 more points. Let's go ahead and find the domain and range, and then let's go see this in Desmos, okay? So domain, what's our domain here? I'm trying to see what other color I haven't used. I think I've used all of them. Let's just do white. So domain and range, remember that's gonna be based off of our asymptotes, okay? We don't have a vertical asymptote that goes with our domain, right? Vertical asymptotes always go with the domain. Since we don't have any, our domain is just all real numbers, so all reals. What about our range? That goes with the horizontal asymptote. We can't have any y values at 0, so it's just y is not 0. Okay, here's our domain and range. All right, let's go ahead and pop over to Desmos, put this in, make sure you have this information down. That way you can reference it. Let's go ahead and put this function in and see if we can confirm all this stuff, okay? Welcome back. Let's do 4 over x squared plus 2. Now, if you just type in 4 over x squared plus 2, that's fine. It'll recognize it as a function, but let's be consistent. Let's actually do f of x, and actually just so I'm doing it the way you guys are doing, and we'll actually do y instead of f of x because I don't remember off the top of my head if it accepts f of x. So we'll do y is equal to, we'll need a fraction bar, so let's do division. 4 in the numerator, and then if you're in the numerator, you can use these arrow buttons to go to the denominator. Just kidding. I think the easiest way to just be press on the denominator. Then we'll do x squared plus 2. So plus 2. Cool, so there's our function, right? Notice how it looks pretty different from the ones we've seen before, right? If we graph 1 over x, y equals 1 over x, right? That's what 1 over x look like. Way different from this red one that we're looking at right now. Okay, and that's fine. Not like we talked about in 8.2, they're not all going to look the same. Okay, especially now that we're getting to the general case, and that is totally fine. All right, so let's go ahead and get rid of this. But let's see, what did we get for our information? We got no x-intercept. From the looks of it, it seems like that's the case. No vertical asymptote. That's also the case. We don't have any parts where the function is going straight up or straight down, and that's usually the case with the vertical asymptote. Now with horizontal asymptotes, we don't ever see them provided in the graph, but if we graph it ourselves, we can do that. Y equals 0, and you can press on this part, you can press on the settings wheel, click on this green circle, and we can change it to dotted or dashed, okay, to kind of give it that effect of an asymptote. And then let's change the color just while we're at it, just for funsies. Okay, so notice if you kind of zoom in, you see that horizontal line. And if you zoom out, you'll see that it'll never, ever, ever cross it, right? No matter how far out you go. Okay, so there's our horizontal asymptote of y equals 0. And then what else do we have? We have a y-intercept that's 0, 2. Is that true? Yes. And we have some other points. We have 1 comma 4/3. Let's go to 1. Just press on where the x value is 1 and actually hold it there. Yes, we see that we have 1.33333, which is 4/3. Same thing with -1. We get -1, comma 1.333. Cool. We got all the right pieces. Very nice. Let's go ahead and keep going. Meet me in the next part of this lesson to do a few more examples. All right, see you there.